Hi. So the next video we're going to be starting a whole new kind of section. We're still looking at fundamentals of game programming, but now we're going to start using a thing called MonoGame. Now, before we get started on that though, a quick word on what that is. So first of all, what's a code library? Well, it is possible to make a game entirely from scratch, at least in theory. But it's more likely that you'll use some code that has been written somewhere before. And sometimes that code is kept in a reusable repository called a library. For example, the math library in C# has functions like cos, sine, absolute, etc. And the console library as well is in there, and the convert library. They're all different classes that are available to you if you use the libraries. But then you can put a bunch of these libraries together and also string them together with a template that creates a framework. For example, the framework we're going to use, called MonoGame, has libraries and templates that will allow us to load textures from the disk, display them on the screen, play sound effects, position things on the screen by using vectors, and it's going to have a main game loop that runs for us. But also, you can go even further. If you have more than just libraries and templates, you may have what's called a game engine. Now, typically, a game engine they're variable, but typically they include these bunch of libraries. They will do rendering for you normally, so you don't have to worry about it. They often have a level editor, allows you to place objects, move them around, change properties of them, customize them, etc. Physics is quite common. We have various types of physics built in, artificial intelligence, and more besides. So there's even a higher step up there. So before we get to that, let's have a quick look at them. Now you can make games just using libraries, as I said. It's particularly easy if they are text-based. Only three good examples of that come to mind, and a couple of those are quite old. Now, as for frameworks, there's a bunch of them about. I'm only going to highlight a few of the most common ones, starting with the Allegro framework. This is based on the C programming language. The only game I could find which is significant made from it was Factorio. There are a bunch of other games, but you probably won't have heard of them. The SFML framework, which is short for Simple and Fast Multimedia Library, it's actually available with multiple languages, and again, a fairly limited selection of worthwhile games made in them, but still some nonetheless. The Phaser framework is what you quite often see in small web-based games, but it does occasionally appear in games you may see on Steam, like a Sparkle on the left there. And it's based on JavaScript. You've got the libgdx framework, which I believe stands for Library for Game Development Extreme, very 90s name there, based on the Java language. There's a few games built in that may be recognisable, particularly the one Ingress, which is the game that was made by Niantic before they went ahead to make Pokemon Go. Now we're using MonoGame. It's based on an older framework called XNA, and there's a bunch of other frameworks which are very, very similar. And they're all based on the C# language, and here's the kind of games that are made in MonoGame and those related languages. And you'll see they have something in common. They're all indie games, not huge budget, not blockbusters, but some of them quite good games nonetheless. Now we move on to engines, starting with RPG Maker Engine, which has a bit of a bad reputation because all the games are kind of the same in some respects. But there's still a few excellent games in there, like To the Moon, which is a critical success there. Barclay Shut Up and Jam Gaiden, which was remade later in a different engine. We've got Box 2D, most famous for various physics-based games like Angry Birds, Crayon Physics, and Happy Wheels. The Ogre engine uses C++, and that's the engine that was used to make Torchlight, Running with Rifles, and a few others. The Game Maker engine, sometimes seen as a sort of younger brother to the big name game engines, but there's still a bunch of names in there you will probably recognise, like Undertale, Hyper Light Drifter, etc. Again, not huge budget titles. But then we move on to the big boys like CryEngine by Crytek, which is based on C++. Some fairly major games there like Far Cry, Crysis. Not Star Citizen, although it was originally made in that engine. It had to move on for legal reasons. Now here's the big one, Unity, by far the most commonly used game engine on the market at the moment. Because it is why it's used so widely, though, a lot of those games are fairly minor. And these are the ones that I thought were worth mentioning. You may notice something in common. They're good games, but not exactly big budget AAA blockbusters. Those are the domain of engines like the real big boys, mainly Unreal Engine, which is also based on C++. You'll see in here the really big hitters: Fortnite, Witcher, Gears of War, etc. I couldn't fit them all on one page. Unreal is just the biggest one on the market for the high end of the games market. These are just a selection of game engines, but there's a bunch that we won't be able to see. We're going to use MonoGame soon. After that, we'll move on to Unity. If we have time, we may touch on a bit of Unreal. We'll see how it goes. But there's some that we can't do because they're proprietary, which means they're in-house and used for only certain games. You may find sometimes they get licensed out. For instance, I think the Frostbite engine was licensed to some other people to build games, but some are very specific, like the MT framework. I think was only ever used for Monster Hunter World, so far at least. So we've already used libraries. We're going to move on to using a framework, specifically MonoGame. As I said before, it's based on an older one from Microsoft called XNA, which stands for XNA is not an acronym, which is a bit recursive, but there you go. So Microsoft stopped supporting XNA. If you look it up online, you'll probably see people saying XNA is dead. It is. MonoGame isn't. XNA is. And MonoGame is like a free open source version of that. So as a result, it's freely available on GitHub. You can see how they do anything that they do, or nearly anything anyway. You can deploy it to PC, various mobiles or consoles. Now, almost every game, no matter what the engine, no matter what the framework, no matter what the language, almost every game follows this pattern. First, you initialize the window and the game itself. Then you begin a loop. During that loop until it ends, you keep on drawing or rendering frames of the screen and separately updating the game world in the background. So things moving around, the physics, the AI, all of that happens during the update. And then you draw a screen on the frame. How many times you do that, it's called frames per second, obviously. So many engines do a lot, if not all of that for you. MonoGame only does some of it for you. So MonoGame has a main function which you're not going to see because all it does really is handle the frame timing to make sure it's 60 FPS or whatever you set it to, and then calls a bunch of functions to do the rest. And that's where you'll fill in the rest of the code. MonoGame's main core game loop looks very similar. So you've got an initialize function, and that actually includes a call to another function called load content, which is used to load in graphics, sound effects, etc. Then it begins the game loop, no function call in there, it's just a loop. It does handle the timing and components and a few other things like that, but basically there's no function there for you to worry about. And until that loop ends, you got a call to the update function, followed by a call to the draw function, and then repeat. That's slightly simplified because you don't always have one update to one draw. Sometimes if there's lag, the timing gets out. But generally speaking, that's how it works. And once your game loop ends, you unload any content. We won't be touching on that because you really only need to manually unload stuff if you do anything funky with memory, because C# has a thing called a garbage collector, a GC, and it's going to unload stuff for you if you don't bother doing it. That won't always happen. If there's some things the GC doesn't understand, you'll need to do it manually. We're not going to that depth in these videos. So let's have a look for MonoGame online. If you just Google for it, or well, I use DuckDuckGo, but if you just search for it, it should be the first thing that comes up. And if we go to downloads, the most recent version is 3.7. I believe what I've got installed is 3.4. I've tested 3.5, but I don't think it's changed that much in recent builds. So you can just download that and install it on top of Visual Studio, and it should start showing up in the templates. So if you click File, New Project, where previously we would check a console application, you should find MonoGame in here. If you don't, that means the templates aren't installed. Now, sometimes in a corporate or educational environment, you don't have, or the technicians might not have full access to your home folder. So if that bunch of templates aren't there, it could be because the IT department wasn't able to put those files in your home folder. They don't have access, don't have permission. So you can just grab a copy of those templates from somewhere and copy them in there yourself. Anyway, so the MonoGame comes with a bunch of different project types. We've got a Windows project, an OpenGL project, which is another alternative, but I'm not going to do that one. You can make Windows 10 project for the marketplace. You can build for Android. I think Ouya has actually been discontinued. You can't get that in the latest versions of MonoGame. Or Linux. You'll notice that there's no iOS or console deployment there. Those are options, but you'll need to have proper licenses for that, and I don't. So we're going to stick with a MonoGame Windows project. So down the bottom here, we've got to give our project a name. I'm going to call it session 7. And do pick a location. I'm going to leave mine there, but there's a good chance the very first time you make it, you'll need to browse and find the location where you want to keep your MonoGame projects. Otherwise, it could go into a folder that's quite a few steps down from your documents folder and might be hard to find. It also can link up with Git. I don't tend to use that because I have a Git Kraken account instead for source control. And you want to leave this ticked for create directory, so that will make a directory to contain all your stuff. So ready to go, click OK. It'll build your project from the template. No code, don't worry, the code's over here. Let's have a look at program.cs, which is what we've been working on. I'll zoom out a little bit. So there's our namespace. It's got a preprocessor command in there, which is telling the compiler rather, only do all this if it's a Windows or Linux program. You can kind of ignore that because we know for a fact it's going to be a Windows program. In fact, you could easily delete that preprocessor command if you want. And we're left, in fact, let's take out the comments as well, just for neatness. And that's a technical thing which I might touch on later on, but it's not really doing much for our purposes at the moment. So there's our main function where the processing starts. All it does is it creates a game1 object. I'll get to that in a minute. So it creates a game1 object, which is the MonoGame game, and it's going to then assign that, store that somewhere. That's a local variable. And then using that variable, we're going to run the game. And that's where all the hidden code is for MonoGame, which, as I say, you can look it up on GitHub if you want to see really how it works. But that's going to handle all the initialize, load content, all that sort of thing, update, draw. So really, program.cs, we don't need. You can close it down and pretty much ignore it forever if you want. Almost everything we're going to be looking at, if not everything entirely, is going to be in this game1. Remember it said in program, using new game1. Here is the game1, and it's based on MonoGame. So it inherits a bunch of stuff from MonoGame. There's no main function in here. Let's get rid of these comments just for brevity. In fact, we'll take out all the comments because I'm going to explain stuff as I go along. You can leave them in. I'm just doing it to make space so that my screen isn't too cluttered for you following along. In fact, I said earlier, unload contents, we're not really going to use it, so we can safely take that out. If the unload content is missing, it won't matter because it's an override and it will run the one from the parent class. So to keep things simpler for us, we'll take that out as well. Because there's already, as you can see, quite enough for us to worry about. I'm going to do Control-MO, that'll minimize them all so we get an overview of what's in a MonoGame project. And that's it, that's everything in a MonoGame project by default. There is a graphics device manager which allows us to access individual graphics devices, video cards. You may have more than one in your PC. So that handles all of those, sets the resolution, etc. There's a thing called a sprite batch. Now this is confusing because there's two things with a very similar name. A sprite batch is something that handles sprites being rendered on the screen in a batch form. So you load them one by one into a sort of buffer and then flush them out onto the screen. So the sprite batch with a capital S, see how it's in cyan, you may remember that means it's a class or something similar to a class. In this case, it is a class. So the sprite batch class has very little code you can actually run, if any. It's mainly used to create objects of that class. So our object is going to be the sprite batch with a lowercase s, and that will be exclusively what we're using. Please be careful not to put this one in, or things won't work. Now, MonoGame has a bunch of stuff under the hood, but the only stuff we're concerned with is the constructor to build your game, the initialization function, the load content to get stuff in from the disk into memory, to update a frame, and to draw a frame. So that's where you put your code. They will all run automatically. You don't need to run them. I say automatically, they'll be run by the MonoGame project, which is done by somebody else. So these will be called for you. You don't need to do that, but any other functions you put in will need to be called by you somewhere in one of these functions. Okay, so what shall we look at first? We've got the member variables up here. There's actually a bunch of other ones, actually, can't think of it, which are built in. Let's open game one. If you ever type in this, the word this refers to the current object. You'll see it highlights game one up there. We're looking at a game one object. So inside the game one object, if you hit the dot reference, you can see things inside it, and then a bunch of events. That's what that little, lightning strike icon there, events. Things with a cube are the functions. Like there's a begin draw and a begin run, which you can mess about with if you really know what you're doing. But our things like unload content, load content, initialize, update, they're all there as well. But you can also find other things, like for instance, the target elapsed time. You can change the frame rate, beg your pardon, by setting how long you expect each frame to take in milliseconds. You can change the size of the window. You can set whether the mouse is visible on the screen. That's just a boolean. Just change it to true or false, and a few other things as well there. There's the graphics that we saw up there, and sprite batch should be in there too. You can exit the game. So there's a bunch of stuff available to us by default. While we're here, this thing here that's called game one, notice it doesn't have void in front of it. So this is a special method called a constructor. It's what's used to construct the game itself, which we've called game one, or MonoGame has called it that for us. You can right click and choose rename. So I believe I'm going to make an egg drop kind of game, catch the eggs in the basket. So let's call it egg drop game. Because I right clicked and chose rename, you'll notice it changed it here. And in fact, if we go back to program, it's even changed it there as well. So if you ever need to change the names of objects, please use right click and rename. Don't do it manually unless there's a good reason to. Okay, so our egg drop game, the constructor, which builds the whole game itself, first thing it does is create the graphics device manager based on this object. And there's another thing in the MonoGame called the content, capital C. Let's get that fix this for us. If you hover over it, you'll see that the content is a type of content manager. So the content manager needs to know where to load in graphics and stuff like that from. So the root directory for that is going to be called the content folder. That'll be a folder on the hard disk to load stuff from. That's all we need to create the very basic MonoGame project. And the next thing it does is call up initialize. Now, initialize at the moment only has a call to the base initialize, and the base object is the MonoGame game. And the only thing that does that we care about is it calls up load content. So initialize is really where you're meant to put in stuff like, I don't know, set how many levels you've got in your game, how many bad guys, whatever, stuff like that, just set up basic data. Whereas load content is to get media assets from disk into memory. And various things similar to that. So for instance, our sprite batch is initialized. We construct a new sprite batch using the current graphics device. And then we've got the update and the draw. By default, the update just has, apart from the call to base update, which isn't too important, but we should probably leave it there for now. The other thing is it checks the gamepad and Xbox gamepad if you press the back button on it, if that is currently pressed, or if you press the escape key down, if you press that down on the keyboard. So get the status of the keyboard, and if you're pressing the escape key, in other words, if you press the back button or the escape key, then exit the game. So this is your quit button basically. You can probably delete that if you don't want to include that, but that is your quit button. And then in the draw function, apart from the base draw, all you've got is a call to the graphics device to clear the screen. If you don't do that every single frame draw 60 times per second, then what could happen is parts of the last frame will be visible in the next one, and you'll get a sort of trail of things moving around, to leave a trail behind them, potentially at least. So that's the sort of basic anatomy of a MonoGame project. And if we just run it just now, you should see that the draw does exactly that. It clears the screen in that sort of cornflower blue color. And there's our MonoGame window, and that's our, oh, I don't want to say our game yet, but it's our program running. We can make changes to it. For example, in the initialize, we can change the window's position. Window, yeah, remember, sorry, this dot window, that's where window comes from. You'll notice I was able to just type window, and that worked as well, because you can actually miss out the word this if you want. I was only including it to be clearer where it's coming from. So this object, the game itself, has a window, and the window has things like, you can see there's various properties in there, but I'm just going to change the position right now to make it a new point on the screen, which will be, have a look at this, an x and a y coordinate of 0, 0. And if we run that, our window shouldn't spawn in the middle of the screen, but in the top left. What else can we change? Well, you can also give the window a title. You could make it borderless. That's a boolean, so we set it to true. Yes, it is borderless. If we run that, that's our window there. You can still hit the escape key or Alt F4 to close it down. You can't click the cross like I did before though. Instead of making it, if you don't like it borderless, oops, sometimes it doesn't quite close down right, you have to hit the stop button. Instead of making it borderless, you could alternatively allow the user to resize the window. Be very careful with this, because the window will resize, but your code doesn't, unless you cater for it. So you might find that only part of your window is now used. Notice the mouse disappears. We can set this dot is mouse visible to true, and then yes, we can now move the mouse over our window. So various things we can do, and probably the first thing you're thinking is, well, how do I change the size of the window? I've got the position, what about the size? Well, that's handled by the graphics device manager. So you can do graphics dot preferred back buffer width. What the heck does that mean? Well, let's put in the preferred back buffer height first. No? So a back buffer is an area of memory which contains a copy of a screen frame which hasn't been drawn yet on the screen but is about to be. And the reason for that is you don't want to did you ever see in our previous projects the screen flickered quite a bit when we were drawing it? That's because things were appearing on the screen one by one. And that will happen in graphical games as well to some extent, unless what you do is draw them somewhere else into a sort of mock-up window, the back buffer, and then push that whole frame out to the screen at one time, so it doesn't build up the window as you're watching. So the width of that back buffer and the height of that back buffer will determine the size of the screen, because they have to match. Now notice it's just called a preferred back buffer width and height. So we're saying to the compiler, try and make a window this size. If it doesn't, if it's not capable of having that size, then things will silently go wrong and you'll need to handle that in your code. But if it's a windowed game, not full screen, then any resolution, as long as your screen's big enough, will be fine. The only time it's going to be a problem is if you make a full screen game with a weird resolution. Now I've stuck with 1024x768. There's no decent PC around today that can't handle that. But if I pick a weird resolution that's non-standard, like 1000 by 700, excuse me, that may seem more reasonable to you, but that doesn't actually match the native resolution of any screen. So as a window, that'd be fine, but as a full screen game, that wouldn't really work. So stick to standard resolutions as much as possible. 1024 by 768 is the lowest standard that's still around, really. You could use 1366, that's another common one. Almost all gaming laptops are capable of that. Once you go above that, you may risk losing potential base to, systems to run it on. So I wouldn't suggest going any higher than that for the moment. Now, if I run that just now, I'm pressing F5 by the way, but that's the same as the start button. That doesn't look like 1366 by 768, does it? Well, let me show you. If I put that code in the constructor, then it will work. That's a 1366 by 768 window. Oops. So basically, if you do it in the constructor, the graphics changes will apply immediately because that's where the graphics device is created. But if you do it anywhere else, you can change the size, but you'll need to call graphics.apply changes. And then it'll work. And that's fair enough, but if you've got that sort of width and height in your game, you probably want to refer to those numbers at various points so you can draw things on the screen, stop things going off the screen, etc. And they're just kind of magic numbers at the moment that are baked into our code, so it's best to do another member variable like this. So I'm going to have a screen width and screen height variable, which are set to the numbers I want, and then I'll copy and paste them in to use those variables instead. We could make them constants actually if you want, but I'm not going to leave them variables so that in theory we could switch screen resolution later on. That's tricky to do, but we'll leave that option open. And if you want to make it full screen, you can just change graphics.is full screen, which see the pop-up, it's Boolean. You can set that to true. There we go, there's our full screen game. Or sorry about that. And obviously you can switch it back to non-full screen by putting it false, but you can also say graphics.toggle full screen. So if it is full screen, it'll become not, and if it's not full screen, it will go full screen. There's another way to do it. I don't recommend that because if it crashes while you're in full screen, then it can, depending on what your system is like, it can make it a bit hard to close down the window. So I wouldn't make it full screen until you're sure it's not going to crash. Maybe leave it in, but comment it out. What else can we do? Well, in the draw function, we've looked at the constructor and put stuff in there. We've looked at the initialize and put stuff in there. But these are all things that happen before the game starts. And once the game's running, there's things you can do as well. So you can set the color of the window. Like it's cornflower blue at the moment. Plenty of other options in there. Goldenrod. It sounds nice, but it's a kind of yucky, dysentery beige color. So you can change the color there. You can also, if you look at the color structure, you can click on it and press F12 and actually see how these things are made up. So colors can be made up of vectors, they can be made up of red, green, and blue as integers or as floats, depending on how you want to define it. So there's various things you can do with that. And cornflower blue is actually, again, cornflower blue is actually a shortcut for this. The color with 100 for a red value, 100 out of 255, so it's not quite half strength red. 149 for green, 237 for blue, so it's mostly blue, a fair bit of green and a little bit of red. Mix them together and you've got cornflower blue, but it's also got a 255, which is the alpha value, which means it's not transparent at all. So that's the definition of cornflower blue, and you can look up a color cube like this, and it will show you how colors are made up. So that's red equal to 255 and the others all 0. That's green 255, that's blue 255, and if you mix them together you'll get a different shade. And you can imagine on the flip side of that cube is the darker shades. So there's plenty of sites online that will help you get whatever color you want. Maybe that's not the best one, but there's plenty of them out there. There we go. Pick a color you like, and it'll tell you the red, green, and blue values in hex or in decimal. There's it is. So that's fully blue, red, green, blue. Let's pick something that's a mixture. Sandy brown. Says that guy's name. So that's 255 red, 179 green, and 102 blue. You might think, well, look at that, it's not very blue, is it? But if you add in all the colours, you'll eventually get to white. That's what additive colour is like. But that's a topic for another time. The point is, you can make your own colours. So the clear command in the graphics device can be using any built-in colour, but you can also make your own colour. So I'm going to create a colour of my own. I looked up the Crayola colours for crayons, and there's one called Alien Armpit. And this is, I kid you not, this is the exact colour of an alien armpit crayon. Red, green, blue, and no transparency. So we can then use their alien armpit colour as the background for the screen. And it's a lovely shade of, wait, that's not right, is it? Ah, typo, that should be 222 there, sorry. It's much greener than that. Yeah, there you go. So I bet you didn't know you'd be looking at the colour of an alien's armpit today. But there you go, you can make your own colours. What else can you do? You can change the frame rate. We won't really see much because nothing happening. Why don't we put in something that will randomly change the color then? So our good old buddy RNG, get it seeded. And if that doesn't show up, you can just put in the using system line up there. Come on, switch to cyan. There we go. So we've now got an RNG which we can use. It's no longer alien armpit, so let's rename that. Random color. I'm using the British spelling of color, but this is an American system, so obviously they spell it without the U. And its color is going to be, well, the red, green, and blue values are going to be a random value between 0 and 256. So red, green, blue, but I'm going to leave the alpha as 255, so no transparency. Oh, sorry, should have given epilepsy warning before that. See, that's 60 frames per second, so 60 times per second it's changing color. That's a bit too fast. That was the point. So we can now change the frame rate, so it's not too fast. This is a bit contrived, but to illustrate how you can change the frame rate, let's go into initialize, because we want it to happen before the game starts. And that's done using, as I said earlier, the target elapsed time. So this is going to be in milliseconds. And it's a time span object. So if we get the time span class and tell it to create a time span from milliseconds and put in 250. So if it's 250 milliseconds per frame, then that's going to be, what, 4 frames per second, which you wouldn't do in real life, obviously, but just to illustrate a point. Now changes color 4 times per second. Slightly less annoying. So that's frame rate, background color, and a bunch of other stuff. In case you're wondering, if you ever wanted to set it to a real value you might actually use, you could make it time span. You could do 16 milliseconds in here. That's going to get annoying having to hit stop every time. You could put 16 in here. That is more or less 60 frames per second. It's 16.66666 repeating, but it's going to be 16 milliseconds for most frames, sometimes 17. Or you can do time span from seconds and see how many seconds it will take for a frame. Well, if you make it 1/60th, don't forget the letter F to make them floating points, but if you make it 1/60th of a second, that'll work out for you and it'll be exact, and you won't need to worry about doing the calculation yourself. So that should be it back to 60 frames per second. But that was horrible, wasn't it? So let's put something else in. We'll have the color interpolate. So we're going to have a current color for the screen. which will start at black. There's a target color that we're going to gradually change to, and for right now I'll set that to white, which is full red, green and blue. And then we're going to have a number that tells us how long we're going to take to interpolate between the black and the white. So it'll start off black and gradually fade in to white over time from 0 to 2000 milliseconds, 2 seconds in other words. So we start at 0, that's the number that's going to change, and when it eventually reaches 2000 we should have switched from this colour to that colour. Still with me? Okay. So how do we do that? Now you might, don't do this yet, but you could do something like this. Take the colour interp time and add on something, the game time, 16 milliseconds. Or to be more exact, you can use this game time variable here that you're given by MonoGame. So if we put game time dot elapsed game time, so how much time has elapsed since the last frame, and get that in milliseconds, that will tell us exactly how many milliseconds have passed since our last frame draw. Hopefully it should be about 16 milliseconds. So that will keep that timer up to date. And then we can make a local variable. I'm going to call it interpolation or interp amount. So that's going to be our color interp time, which is going to go from 0 upwards. And divide that by color interp time max. So that's out of the 2000. So it's going to start at 0 out of 2000 and then go to 16 2000, 32 out of 2000, 40 out of 2000. So it's gradually going to move up until it reaches 2000 out of 2000, which will be full interpolation. So in other words, that interp amount is going to go from 0 to 1 very gradually. Well, not very gradually, over 2 seconds. So as it does that, oh, actually, that's not quite right, because even though interp amount is a float, these two are integers. So color interp time and color interp time max are both integers. And if you divide one integer by another, you could end up losing a fractional part, a decimal part, and it could actually end up 0 when it's not meant to be 0. The interp amount is meant to go from 0 to 1, so nearly always that data is going to go missing. So we'll just have to cast it to a float before going ahead and doing it. So take those numbers, treat them as floating points, and then we'll get our interpolation amount from 0 to 1. 0 representing, of course, the black color, and 1 representing the target color, but the computer doesn't know that yet, so I guess we better do that as well. So how much red should it have? Well, we're going to do a thing called LERP, linear interpolation. So what that does is you give it a source value, a target value, and an amount to go in between them. Oops. No, what have I done there? Oh, I don't have a source color. I guess I better put in a source color. I've got current color. Let's call that source color. Still doesn't seem to like that. Okay, why is that? Cannot implicitly convert float to int. Oh, right, we're lerping between two values. So the red value for the source and the red value for the target, I've put them in as integers, but the color itself, although it takes those integers, it's going to convert them to floating points internally, which is confusing. So they're going to come back out as floats, and it's going to interpolate between those floats. So it'll give us a float. We'll have to turn it back into an integer. Okay, same for green and blue. But obviously that will use dot G instead of R and dot B. We'll use the same interpolation amount because it's going to interpolate between them for all three colors. No longer need a random color because the color we're going to use is going to be a new color using the red, green and blue values and full full opacity there. So there's our new color. Will that work? Have I messed anything up? Let's see. No, there we go. Black to white. There's a nice fade for you. So that's linear interpolation. It goes on a line between black and white. This isn't really necessary, but let's take it one step further before we finish up. So what I'm going to do is, oh, still running. Oh, by the way, I'm pressing Shift F5 there instead of the stop button. That's why I'm a bit quicker. So if our interpolation amount reaches or goes past 100%, go past 1, so it goes from 0 to 1. Once it reaches 1, we're just going to reset the timer for now, and it should go from black to white and then back again. Sort of pulsing color, but I'm not going to leave it there. Let's change our source color. We've now reached what our target was, so let's call our what was our target our new source. So we're going to start from the color we ended up at. Oops. Start from the end of the old color, and then choose a new target color. So random red, green, and blue, and fill opacity. That's just a bit long. Let's make it fit on one line. So we pick the next random color. So once we reach the color we want, we're going to take that color that we did want and start from that color and go towards another random color. Now it doesn't start off random, it goes from black to white. But once it reaches white, it should pick a random color and go to that. And then when it reaches purple, go to a different color, blue, brown, and so on. So we now have interpolation with random colors. Okay, so there's loads more stuff we could do, but I think I'm going to leave it there for now, and we'll carry this on later.